Hello and welcome to the Scalable Agile DevOps course using Git, Docker, and GitLab. In this module, we are going to be looking at Docker in particular because Docker allows us to automate our whole build environment and to be able to replicate it from scratch. So Docker is a central part in creating a scalable CI/CD pipeline because we can always go back to an older version of our build environment and rebuild our application exactly the way that it was built before. Let's go ahead and create a very simple Docker file. The simplest Docker file you can create looks like this. Basically, we say to Docker that we want to create an image based on Ubuntu 23.10 image. So that's going to be our base. This image is around 70 megabytes big. It contains the basic Ubuntu installation. And then we specify command line arguments that we want to pass to the default shell when the image runs. We can build and run this image using Docker by specifying Docker build and then the file that we want to build. So that would be our Docker file that we just written. And then we also give a name to the image. And the last dot on the first command, that specifies that we want to use the current directory as the context for building the image. So if there's any copy commands or add commands in the Docker file, Docker is going to take those files from this current context. And lastly, once we've built the image, we can run this image by typing docker run and then giving the name of the image. And the rm argument that I've passed to this run command ensures that the container is removed when the default command that runs inside the image exits. And this ensures that we don't have any dangling containers afterwards, after the image is done executing. In Docker, there is multiple ways that you can start your Docker containers. The simplest one is just docker run and then giving the image name for the container that will create a default container, and it will then run the default entry point of the container, which is going to be bin show. If you don't specify the default entry point, Docker will just run the default shell. The second way you can run your image is by supplying additional parameters, which is ti, which ensures that the Docker process that runs inside Docker is going to be executed with terminal and in interactive mode. When you run it this way, then any program that you run that is interactive, such as, for example, the shell, or if you start a text editor inside Docker, it's going to behave correctly. And lastly, we can start any command inside an already running container using Docker exec. In which case, Docker is going to try to connect to the container, run the command, and it's going to print out all the output from that command. So in this way, you can, for example, start a shell inside the container by typing docker exec container name and then bin bash to start a shell inside the container. Docker is created by Docker Inc., which is an American technology company that develops productivity tools built around Docker. And one of their products is the Docker Hub, which contains many pre-built images that you can use right out of the box. One of them is, for example, the official Docker image, which you can use to build Docker images in CI/CD. You can search Docker Hub directly from command line by typing docker search and then the name of your image. And you will get a list of images from Docker Hub that you can easily pull using Docker pull. So you can type docker pull and then the name of the image, and that will pull the image to your computer, and then you can run that image and any tools that are contained inside that image. So for example, for running Node.js applications, you can pull the official Node image, and you can then run Node inside that Docker environment, which will have access to all of the Node.js executables and npm and all the other tools that you need in order to run a Node.js application. So this is very convenient. We can build our own environments in this way, and we can version them, we can reuse them, and they're all versionable in Git because they're expressed as text files, as our Docker files. And we can also push them to Docker Hub so that others can use them. So let's look at how we can create Docker files. Docker files are basically lists of commands to Docker, and there is just only a handful of these commands, which are very powerful when you combine them together. And here you can see the full list of all available Docker commands. By putting these commands, combining them into Dockerfile, we can build very complex images that can even contain a full-fledged Ubuntu system that is built from scratch using a specific version of Ubuntu and specific packages that we want to include. So let's look at each one of these commands in sequence, and I'll give you a brief explanation of how each command works. And hopefully this will give you a good introduction to Dockerfile so that you can start creating your own Docker images. The first command that you've already seen is the from, which specifies the base image. And you can also give it an alias. So for example, you can type from Ubuntu 22.04 as base. And then when you run subsequent commands after this line, those commands will be used to build this image, which you can now reference as base. So if you, for example, run a compile command inside as part of your build process, let's say you build some tool, you can then copy those artifacts from a specific base without including all the packages that are that have been downloaded and installed in the original image. So you can say, for example, from scratch and then copy from base and path to the files that have been built as part of building the base image. And this is actually going to be a completely new image. So you can then save this image and it's going to contain only your final executable. So in this way, we can write complex multi-stage Docker files that first build an image in order to run the build process and then execute the build process and then finally build the image that only contains the artifacts that have been already compiled. And the most common command you will use inside a Docker file is the run command. The run command executes an arbitrary Linux command inside this Docker environment. And in this way, you can install packages, for example, by calling apt-get. So we can say that apt-get update to update the sources, and then apt-get install, and then we can install any packages that we want to install inside the Docker image. And the reason we need to have apt-get update in the front is because by default, our starting point doesn't contain any of the sources. So we have to initialize the environment. And we don't want to do it as a separate step either, because we don't want to store those sources and additional packages that are just downloaded and cached. We want to clean them up after we have installed those packages. So when you execute the run command, usually you run it in a single line, and you will have many of those and signs that you use to string together multiple commands. And when you use the and sign, it means that when the command runs, then both sides of it have to exit with success. If any one of those commands fails, then the whole run command will fail, and your build process of the Docker image will fail as well. The entry point command in Docker allows you to specify the default executable that will run when you execute the Docker run command. And the CMD options that you've seen earlier, those are the parameters to this default executable. So entry point is the default executable. And by default, it's just going to be the default shell. So if you don't specify anything, any command to run, then the shell will just exit, and then the image will not produce anything. But if you specify additional parameters, then the shell is actually going to execute those commands that you specify in the CMD option. But you can change the default executable by using the entry point command. So in this case, we can set it, for example, to bin bash, or we can set it to Node.js, and we can also supply non-overridable parameters as part of the entry point command. So in this case, we specify node, and then we want to run my app.js. And if we now try to add additional parameters using CMD, then we can override them on the Docker command line. And if the user then supplies additional parameters to Docker run, then all of the parameters that we specify with CMD are going to be overridden with the parameters that user specifies. And in this way, we can, for example, have an image that has the entry point Python to run the Python interpreter, and then it can have a default script to run. The user can then override this default script and run their own script using the same Python interpreter. The label command allows us to add key value pairs to the image. We can, for example, specify maintainer, we can specify site URL, and any other arbitrary labels. So this is basically like key value pairs, and they will be available to us if we do Docker image inspect, and we can then query those labels in the image. So we can store certain configuration options, we can store metadata in this way, and we can then query it. Then we have the Docker expose command, which allows us to expose ports inside the Docker container. If we have, for example, a web server listening on port 80, we can use the expose command to expose this port outside of the container. And Docker will use this port to automatically adjust the firewall rules to allow clients to connect to the IP address of the Docker container on these ports, and the connections will be then forwarded to the application that is listening on that port. The env command allows us to supply default environment variables that will be accessible inside the build process of the Docker container. So we can set an environment variable like this, and this environment variable then becomes available to us everywhere in the build process, including also commands that we run in the image afterwards. The copy command allows us to copy files into our newly built Docker image. We can use the copy command to take anything out of our current Docker context. And if you remember, when we run the Docker build command, we supply the current directory as the Docker context. This context is then sent to the Docker daemon. And not only that, we can copy the files from the file system, we can also copy them from intermediate images that we have built as part of the Docker build process. So we can say that we want to copy something from the base image and then supply a source folder and the destination folder. And then we have another addition to the copy command, which is the add command. And the only difference between add and copy is that add supports URLs. So add is able to automatically download and extract a tar archive into a directory inside the Docker image, whereas copy is an older parameter that doesn't have this functionality. We can also create volume mount points inside of our Docker image that would be automatically placed on a separate overlay file system that will be outside of the main container. So when we run our container, the volumes will automatically be created, and then any data that is written to the volumes is going to be stored, even though the container might be removed later. So for example, if we have volume workdir inside of our Docker file, then anything that an application writes to workdir is going to be placed in a separate file system that we can then export. And we can also add additional content to the volume. So we can copy files to that directory, and then we can specify the volume. One important detail to note is that anything that we copy to the volume directory after we have specified the volume is actually not going to be visible afterwards. It's only the files that we copy to that location before we specify the volume that are going to be visible inside our Docker image. We can also persist volumes across containers. And in order to do that, we can create a default container that will have the volumes automatically created. And we can then reuse the volumes from that container to start new containers. And all of these containers are then going to be using the same volumes as the original container. So any data that is then saved to these volumes is going to persist, and it's going to be reused when we start new containers. Then we have the user command, which allows us to change the user during the build process. So if we want to execute some of the run commands as root, we can say user root, or if we want to execute them as conventional user, then we can type user. The workdir command specifies the default working directory of the image. So when we start the default application, that is our default entry point, then that application will be running in the current working directory, which will be set to workdir. So in this way, we can say that we want to start our default application in the location of workdir. The arg parameter defines variables that the user can pass at build time to the build process. So they're kind of like env, except they don't end up as actual environment variables. They are used as arguments to the build process itself. And arg is useful for example, specifying versions of packages that we want to install in our Docker image, so that we can have all of these versions specified at the top of the Docker file and then just use named variables in places where we need to install packages. The onBuild command is used to trigger an instruction to be executed on build time of a different image that builds from our image. So let's say we want to run some install process or run some configuration process on another image that has from and then specifies our image as the source of that image. We can use onBuild command to defer certain steps to the build process of that additional image that is built downline. So for example, if we have an image that looks like this from Ubuntu and then onBuild run some command, then when we have another image that specifies from demo, which was the previous image that we built, and then executes a second command, then when we build this second image, then both commands are going to run as part of the build process of the second image. The stop signal command allows us to define the signal that's going to be sent to the default process. So in Docker, when you run an image, the first process that is started is the default process. And then, of course, this process can start additional processes. But when you stop your image, then by default, Docker is going to send sigterm to the default process. And by using stop signal command, we can change that default behavior, and we can say that, for example, it would send sig user instead of sigterm. Then we have the health check command. This is useful to check the health of the running Docker container. And Docker will run this at specified interval. And if this command fails, then the image is going to be considered broken. And so Docker will follow the policy that you specify when you, for example, create your Docker Compose file. And usually you want to just restart the container if you discover that it's broken. So health check can be used for this purpose to run an arbitrary custom script at given intervals and check that the container is in good health. The shell command is for specifying the default shell that is used for shell commands in the Docker image. And also, if you don't specify any other entry point, then shell is going to be the default shell that's going to execute your main application or any parameters that you pass to your Docker container when you start it. The Docker ignore is useful for limiting the context that is sent to the Docker daemon when you build your Docker image. And this greatly increases the efficiency of the build process. You can, for example, avoid sending large Git folder, or you can avoid also sending build artifacts to Docker when you build the image. And that makes your build process faster. But not only that, this also is much safer because you might have some passwords or some login details in your, for example, environment files, and you might not want to pass that to the Docker build process, because then there is a chance that those things would be included in the final Docker image. So Docker ignore gives you the same approach as you would use with Git ignore, to completely omit certain paths and certain patterns from the files that become accessible to the Docker image build process. Next, let's look at mounting Docker volumes. By default, Docker doesn't mount any volumes inside the container environment, but you can explicitly expose host file system folders to Docker and to make them accessible also from within the container by using mount points. And internally, Docker uses bind mounts, which is similar to how you would mount a directory in Linux using mount --bind command. But in Docker, we basically call them volumes, and we can specify the source directory and the target directory where this source directory is going to appear inside the containerized environment. So if we run docker run and then -v, and then we can take, for example, current working directory, and we can mount that in /code inside our Docker container. And if we then try to list the contents of this code directory, we will be listing the contents of our current working directory. We can also use volumes to mount devices, because in Linux, everything is a file. And so if we mount some directory under dev and make it available to the containerized environment, then we can access the same devices that we would be able to access on the host file system. This does have some limitations though. Number one is that, of course, you have to run Docker in privileged mode to use this particular method of mounting devices. There is another command called device where you can expose specific devices to the container, but there are still limitations with respect to what it can do with those devices. You might not have fully functioning devices if you mount them this way, but usually for the most part it does work, and it allows you to access both devices for flashing firmware to your embedded systems or accessing serial ports and most other devices. Now let's look at networking. In Docker, we can create isolated networks to which we can connect our virtual environments that we create using Docker containers. And those virtual environments then kind of behave like separate machines, but they're not actually separate machines. Docker uses C groups and basically partitions permissions to containerize the application. They're still running as normal processes on your PC, but they still have their own IP addresses, and Docker automatically handles the firewall rules to make sure that those machines cannot access things that they're not supposed to access. So for example, you can have a private network that you create just for a few Docker machines, and maybe they can access the outside world, but they wouldn't be able to access other machines that are on a separate Docker network. So in this way, we can isolate machines from each other, and we can also give access to groups of machines so that they can have free access to each other. And one example of this is running an application and a database server. So for this purpose, we would create a network, and then we would attach both Docker containers to the same network so that they can access each other. We can also push our images to the default Docker IO repository. You will need to register an account at Docker IO. And once you've registered an account, you can use Docker login in your terminal and then enter the details. Usually it will ask you for details only once, and after that you will be able to push your image to your repository that you've created. By default, Docker IO does not allow private images, so if you want to have private images, you can create a paid account at Docker IO, and that would give you possibility to have private images. Docker login is convenient for CI, but if we use it in CI, then we need to modify this command a little bit, and we need to provide the username on the command line, but then we wouldn't provide the password on the command line. Instead, we would use echo and then pipe the CI Docker secret, which we set as a variable. And then if we have this variable as a protected variable, it's not going to appear in any output in GitLab CI, so it's going to be protected. If we want to push Docker images to an arbitrary Docker image registry, then we need to name the image itself with the URL included. So if we exclude the URL, if we call this image, for example, demo, then when we try to push this image, it's going to try to push it to the default Docker IO URL. But if we want to push it to GitLab, for example, then we need to specify the full URL to the location where we want to push it, and we need to actually use this full URL as the name of our image, so that we can then call Docker push, and when we push that image, it's going to automatically use the URL part to determine where to push this image. And in some cases, we don't want to push it to a Docker registry, but rather we want to push it to another machine. A very convenient method of doing so is using a combination of Docker save, SSH, and Docker load. So we can call Docker save, then provide the name of the image, and that would output the image to the std out of Docker save command. And then we pipe that to SSH, and we run Docker load on the other end, which will then accept this output of Docker save command, and it will actually recreate the image on the other side. We can also use Docker stats command to view the status of currently running containers, including the memory usage, the net usage, IO, how many processes have been started, and the name of the container and the container ID. And another convenient thing is the Docker logs command, which will print out the logs from the running container, and it actually persists the logs over multiple runs of the same container. So if you restart your server, you can always still use Docker logs command to print out if there is to print out the logs so you can inspect them to see if there is any errors. Normally, when you use Docker, you would be running it through a system like GitLab Runner that will start a container for your build process and then actually run the whole build process inside that container. But sometimes you don't want to use like GitLab Runner. Maybe you just want to create an alias in your shell environment, or maybe you just want to have a makefile that is capable of building both inside Docker and also on the host system. And this is an example of how to do this. So here we define our image as a variable, and then we have a conditional where we say that if Docker is empty, then we set the run command to be Docker run, then this cleanup flag we want to run in the terminal. We want to mount our current directory under workdir. We want to mount our SSH keys. We want to set our workdir to workdir. We want to set our user to use the same user ID and group ID as our host user. And we want to run our image and then run anything that comes after this inside the Docker container. So we can then use this by simply referencing this run variable and providing the command we want to run inside Docker. And make will automatically then expand this to the full Docker command. And this makefile will basically build by default inside Docker. And then if we set Docker to 0, then it will build using normal commands. And you might have seen the user ID that I've provided in the previous example of the makefile. This would be the user ID that Docker will use to set the default owner of the files that you create. This is especially important if you're mounting your host directories inside Docker, because then if you're running as root inside Docker, then the files that Docker creates are also going to be owned by root. And obviously, if they're created inside your directory, it's going to cause you problems. So this is a way of specifying that you want to be using the same user ID that your current host user is using, and then pass that user ID to Docker as well. We can also limit the resources that Docker has access to by directly specifying those limits as part of the Docker run command. So we can, for example, limit the amount of memory that Docker uses, and we can also limit the number of CPUs that the Dockerized application uses. So in this way, we can partition our resources among multiple Docker containers and ensure that no single container can take over all of the resources. And finally, when we are working with Docker, occasionally we want to clean up our environment. For this purpose, we would use Docker system prune, and you can also use Docker system prune volumes if you want to delete volumes as well. Now, since volumes can sometimes contain information that you might want to keep, or in case you're reusing volumes, then you wouldn't want to delete the volumes. But for the most part, when you're using Docker in a way of like automating CI build processes, you can just delete all the volumes. Thanks for being part of this presentation, and I hope this was useful as a very short introduction to Docker. We are going to be diving more into Docker as we look into GitLab CI setup, where we will be using Docker images and actually running our build process and automating the whole build process in multiple stages. But we cannot just do that with Docker. We need to learn GitLab CI first so that we can then orchestrate Docker builds using GitLab CI.